Very good afternoon. I welcome you all to this live session. I request the registered students, participants of this particular course, Thermal Engineering Basic and Applied, to raise your question if you have any, so that we can start our discussion now. I request all registered students of this course, Thermal Engineering Basic and Applied, to raise your question in the chat box if you have any from the modules you have already completed, so that we can start our discussion right now. I can see a few questions already raised by Professor Sanjay Mitkari. He's a faculty. So let me discuss all these questions first. Then I would request you all to post your question in the chat box so that we can start our discussion. Before going to address those questions raised by Professor Sanjay, I would like to say here that this course, Thermal Engineering Basic and Applied, has several modules, and through these modules, I have tried to discuss the basic part of thermodynamics. Then we have started our discussion on the applied parts. You had seen perhaps by this time the modules like steam power plant, internal combustion engine. Then in a steam power plant, there are several sub-modules like basic cycles, then boiler, that is steam generator. We have also discussed about the nozzles, which is an important part as well for the steam power plant. Then we have discussed about steam turbines. We have discussed about condenser, cooling tower, and then we have discussed about other modules like gas turbine units, vapor compression refrigeration unit. So the questions raised by Professor Sanjay. The first question is, in the statement of second law of thermodynamics, nothing is mentioned about the entropy, but still we say that entropy is given by second law. Thank you very much for this question. In response to this question, I would like to tell you it is true that nothing is said about the word entropy in the statements of second law. We have talked about two different statements, Kelvin-Planck statement and Clausius statement of second law. But I should tell you that there are many corollaries of both first law and second law. Entropy is a property, and that is an important corollary of the second law. Though this word is not mentioned neither in Kelvin-Planck statement nor in Clausius statement, but this is an important corollary of the second law. In this context, I'd like to tell you that if I ask you the second law of thermodynamics by using the word entropy, then second law can be also, analyzed that, or second law states that entropy of the universe is always increasing. Entropy of the system may decrease or increase, but entropy of the surroundings is always, increases. But entropy of the universe, that is system plus surrounding, always increases. So though the words entropy is not there in the second law statements that you have already studied, but the word entropy which is an important corollary of the second law. And using the word entropy, second law also can be, stated that entropy of the universe is always increasing. You know that if you try to recall, though this is an important part of the basic thermodynamics, rather, fundamental part, I should say. But since you have raised these questions, I would like to discuss here briefly that first law cannot provide the direction of a process, while second law certainly can give us directionality aspect of a process. Now, whenever there is a process, we have though discussed about thermodynamic equilibrium, that is thermal equilibrium, mechanical equilibrium, and chemical equilibrium. But had all these equilibriums maintained, then there would be no process in reality. So, if there is a process, we need to, violate all these equilibriums. We can consider that process is quasi-static, then only we can assure that local equilibrium is maintained. But in reality, no process is quasi-static. Hence, and say for example, if there is no any pressure difference, flow will not be there. If there is no any heat temperature difference, heat transfer will not be there. So if there is an imbalance in force or pressure, imbalance in temperature, certainly it will violate equilibrium. But to have a process in real applications, we need to violate all this. So when there is a process, it is very unlikely that the process can be explained through a series of equilibrium states. Though we had tried to analyze all these processes in different thermodynamic planes, assuming that process is getting executed through a series of equilibrium states. But in reality, it is not a case. A spontaneous process will certainly invite to some extent irreversibility, and that particular aspect is characterized by this important thermodynamic property, that is entropy. So for your information, though entropy is not there neither in Kelvin Planck nor in Clausius statements, but this is an important corollary of the second law of thermodynamics. Second question that you have asked, at critical pressure, nozzle is said to be choked. But why do we say like that? Again, thank you very much. So when there is a flow through a nozzle, particularly, that we have talked about flow of steam, and we have assumed that this is a flow of a compressible fluid. And if we need to have a flow of steam through a nozzle may be of convergent divergent type, it may be of convergent type. If it is of convergent divergent type, there must be a area which is having almost equal cross-sectional area, and that is called as throat. So when there is a flow through a nozzle, certainly to have or to maintain the flow, there must be a drop in pressure. And at the cost of this reduction in pressure, the sole purpose of having this particular unit, that is nozzle, is to increase the kinetic energy or velocity of the steam, so that steam that comes out from the nozzle will be having high kinetic energy. So if we talk about a convergent divergent nozzle or simply a convergent type nozzle, in the direction of flow, area gradually decreases, and it is because of this decrease in area, velocity will increase, pressure will decrease. So there is a critical pressure for which, so that means if we consider inlet section and outlet section, and if we can reduce the pressure at the outlet section, then that reduction in pressure should be sensed by the inlet section, and then only more amount of flow or more amount or large amount of steam should be allowed to flow. When pressure at the exit or pressure ratio is the critical pressure ratio, that means P2 by P1, if we consider section 101 is the inlet section, section 22 is the outlet section or exit section, then pressure ratio P2 by P1. When P2 by P1 is, P2 by P1 critical, that means P1 is fixed, but if we reduce P2, then only we'll be having flow. So when P2 is P2 critical, then we'll be getting certain amount of mass flow rate of steam, because here it is a compressible fluid flow. So density will continuously change in the direction of flow. Now, when the critical pressure ratio is attained, a further reduction in pressure at the exit will not be sensed by the inlet section, and hence no further increase in flow rate will be there. And that time the nozzle is said to be choked. That means at the critical pressure ratio, the flow what is there, that flow will remain same even if we reduce the pressure at the exit of the nozzle for a given condition. And that reduction in pressure at the exit, if we need to percolate through the fluid, compressible fluid medium to the inlet section, then only more amount of steam or more mass flow rate will be increased. But we have discussed in the class that a reduction in pressure, that is, we are going to have a disturbance. That disturbance should be conveyed through the compressible fluid media to the inlet section as a sonic velocity. Now, when critical pressure ratio is there, the velocity itself is a sonic velocity. So a further reduction in pressure, that means a further disturbance won't be able to move to the inlet section because the velocity is already sonic, and hence there will not be any further increase in the mass flow rate, and that is the condition when a nozzle is said to be choked. That means no further enhancement of mass flow rate will be there. If we come to the third question, temperature decreases in radiative superheated, whereas it increases in convective superheated. It is not superheated, it's superheated. Convection and radiation are the modes of heat transfer, and there is simultaneous heat transfer due to convection and radiation. So how can we separate it and analyze? If we really need to go for an analysis focusing on the rate of heat transfer both in radiative or radiant and convective superheaters, we can do it. But we have discussed about that radiative superheaters are placed in a zone inside the boiler wherein temperature gradient is very high. Now, if we now increase the mass flow rate, that is load of the boiler, then with increase in mass flow rate, certainly convective heat transfer rate will increase. But for a given temperature gradient, if we now use more amount of steam, which is yet to be superheated, then with increase in load, the radiative transfer of heat will decrease because the temperature gradient is remaining constant. Instead of M1 kg of steam, if we now allow M2 kg of steam, where M2 is greater than M1, essentially to meet the demand or high demand from the boiler, then this radiative or radiant or radiative heat transfer will decrease, but with increase in the mass flow rate, convective heat transfer will increase. So this is basically the understanding perhaps you have gathered from heat transfer course. But if you really need to analyze the rate of heat transfer that is there in a convective superheater and rate of heat transfer that is there in a radiative superheater, we can do. But if I can recall correctly, I had tried to discuss it using a graphical presentation that with increasing load, what would be the heat transfer rate. So this is quite obvious that for a given temperature gradient that is responsible for the radiative transfer of heat, if we increase the load, heat transfer rate will decrease. And that is what I had discussed. So now if I come to, the question, so I can't see any questions in the chat box. So I shall request learners, students who have registered with this course and those who are attending this live session to post your question in the chat box so that we can start our discussion now. What is the difference between ambience and environment and surroundings? See, anything external to the system is surroundings. Ambience, that basically what we need, what we have discussed. Ambient condition, that is the condition which is the normal temperature, pressure, etc. But anything external to the system is surroundings. So if we consider, say for example, even if we consider a system inside a room, and if we consider a small system confined in a chamber, outside this chamber is surroundings. So with respect to that system, anything external to the system is surroundings, but inside the room, the temperature and pressure or any other thermodynamic properties, pressure, temperature, etc., may not be the ambient condition. So ambience and ambient condition is the normal temperature, pressure that we typically consider, and the surroundings is basically anything external to the system. Yes, so I request students, learners who are attending this live session to post your question in the chat box so that we can start our discussion now. I may mention here that in this particular course, there are several modules, including one important module that is basic thermodynamic part. So basic thermodynamics, what we have tried to discuss in this particular module is the recapitulation of our understanding. Then we had discussed about several other modules. Those are related to the applied thermodynamics part, starting from the steam power or vapor power cycle, then different modules of the steam power unit, discussion about the boilers, then flow nozzles, then turbines, condensers. We have also discussed about gas power cycles, gas power units. We have also talked about vapor power cycle, wherein the objective is not to produce power, but to produce refrigerating effect. And for this part, we have discussed about vapor compression refrigeration system. So I hope you have already gone through a few modules of this course. And if you have any question, I request you all to post your question in the chat box so that we can start our discussion on those, aspects. I may mention here that it is not mandatory that you have to post your question here. Even if you have any questions later on, you certainly can post all those questions in the discussion forum. You also can email me the questions. I shall get you back with the answer of those questions. I request the students and learners who are attending this session and have any questions, have any doubts, to post them in the chat box so that we can start our discussion. In addition to the, vapor power cycles, gas power cycles, we have discussed about internal combustion engine, and we have discussed the basic parts, including air standard cycles. Then we have also discussed about fuels. We have briefly discussed about the combustion. So if you have any questions from those parts, at least the modules, those you have already, completed, please post them in the chat box so that we can start our discussion. You also can post your question in the discussion forum later on this session, and I shall be happy to discuss those questions. You also can email me the questions or any doubts if you will be having later, and I'll get you back with the answer of those questions. I request the, registered students, learners, those who are attending this session, or already if you have any questions from the modules that already you have completed, kindly post them in the chat box so that we can start our discussion now. This course, Thermal Engineering Basic and Applied, which is certainly an amalgamation of basic thermodynamics as well as applied part of the thermodynamics. And to understand several applied components of thermal engineering, an important part is the understanding of the basic thermodynamical aspects. So in this particular course, in addition to those applied parts, we have discussed about the basic thermodynamics. Just to recapitulate, the several aspects, those are very much important to understand several processes, several aspects of the applied components. Then we have talked about the steam power cycles. Then we have discussed about steam power units, including boilers. We have discussed about several cycles inside the boiler. We have talked about the boiler efficiency. Then we have talked about a very, very important component of the steam power cycle is the flow nozzle. because flow nozzles are very important to increase the kinetic energy of the steam jets before steam enters into the turbine. Then we have talked about steam turbines, different efficiencies, then the blading diagram. We have also talked about another important component of a steam power plant is the condenser. We had seen that even in absence of condenser, we can run a steam power unit. But in that case, it is not possible to run the unit in a cyclic manner. If we need to run the system in a cyclic manner, as we have studied in second law of thermodynamics, that there must be a heat sink. So condenser is essentially, act like a heat sink, and boilers act like heat source. So we have discussed about the condensers, the mechanical aspects of the condenser design. We have also discussed about the processes. Those are there inside the condenser. Then we have talked about air standard cycles. Those are used to, compare the processes in internal combustion engines. We have discussed about several, components of internal combustion engines, including both petrol and diesel engine. Then we have talked about the vapor compression refrigeration system, essentially a vapor power cycle, wherein the sole purpose is not to produce power but to produce refrigerating effect. We have also discussed about gas power units, and we had seen that gas power units are basically, used as the peaking units. To this end, we have discussed about both closed cycle gas turbine unit and open cycle gas turbine unit. We have talked about combined cycle because, efficiency of the gas turbine plants are not reasonably high. So, you know that a concept is the combined cycle wherein the heat or energy discharged by the gas turbine can be used to, increase the or change the water into steam. Water can be converted to steam by taking that heat, and that steam can be again used to run another unit, that is the steam power unit. So this part also we have discussed. I request you all, if you have any question, to post your question in the chat box so that we can discuss them now. Even if you will have questions later on, you are requested to post your question in the discussion forum. You also can email me the questions. I shall be happy to address all those questions. And already, if you have any questions from the modules you have completed by this time, and or any doubts, please post them in the chat box so that we can start our discussion now. I can understand that there are no more questions in the chat box. The questions raised by Professor Sanjay, I have tried my best to discuss them. I also would like to request Professor Sanjay, if you have any further questions from the remaining modules of this course, kindly feel free to email me all those questions. I shall be happy to answer them. students, learners, those who have registered with this course and those who are attending this session, I request you all to post your questions if you have any in the chat box so that we can start our discussion. If you do not have any question, then I would like to complete this session for the day. But I request you all to post your question, even if you have later on this session in the discussion forum. And you also are requested to email me the questions, doubt, if you will be having any further from the remaining modules of this course. So since I can't see any questions in the chat box, I would like to, stop here today. But at the same time, I request you all to post your question in the discussion forum. Even you are requested to email me the questions, and I shall try my best to address those questions. Thank you.